Hello, my name is Brendan Hall. I'm a part-time student on the Applied Cybersecurity Master's Programme at Dublin Technological University, and I'm here today to present my research project proposal. The title of the proposal is Utilising Shodan to Demonstrate the Extent of Vulnerable IoT Devices in the UK and Ireland Regions, a Scalable Approach. Today I'm going to cover the motivation behind the project, the research questions and how I arrived at those questions. I'm also going to cover the proposed methodology that will be used throughout the project, the results evaluation, how the data will be evaluated and presented, and I'll also cover a detailed project plan. This section will cover the motivation behind the project, what is the problem being assessed and why it is a problem. But first, a brief introduction to the Internet of Things. The Internet of Things can be described as a system of interrelated computing devices, machines, objects, animals or people that have the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. So you can see from this statement that this covers a vast range of possibilities. So what is the problem being addressed? We want to determine the extent of vulnerable IoT devices that are currently connected to the Internet. Today it is estimated that there are 26.6 billion devices connected to the Internet, and this is estimated to rise to 75.4 billion by 2025. In the early development of IoT devices, focus was put on time to market and cost by manufacturers, and security was lacking. So this has meant that a large proportion of already deployed devices have exposed vulnerabilities which are being exploited by cybercriminals. Also, another problem being addressed is the fact that no scalable approach has been developed to quantify the size of this problem by previous researchers. So why is this a problem? Well, devices can be easily identified using Shodan search engine. Once identified, devices can be assessed for vulnerabilities and those can be exploited. And cyber criminals have started to monetize these exploits in the IoT space. Services are being developed for hire and numerous attacks have already been perpetrated using IoT devices. This graphic, which is taken from research conducted by Trend Micro in September 2019, shows a number of discussion topics which have been extracted from IoT discussion forums used by underground cyber criminals. We can see here that Shodan is quite prominent, and also the number of services that are for hire is quite large. So you can see that this is a growing problem and it's only going to get larger. Research questions. In this section, I'll explain how I arrived at a set of research questions from review of current research in the area of vulnerable IoT devices. In order to reach a set of research questions, a literature review of IoT device vulnerabilities is undertaken. This is a very large area with a significant amount of research. So the initial scope was reduced to device identification by scanning the Internet for IoT devices. Research in this area from 2014 to 2019 used Shodan for device identification, but most of the research was limited to specific device types and specific regions. There was no attempt to measure the true extent of the problem. There was no scalable approach to determine the extent of vulnerable IoT devices, and there was no previous research targeted at the UK and Ireland. So this led me to formulate the following research questions. Can Shodan be used to demonstrate the scale of vulnerable IoT devices? Can a scalable approach be developed using a regional target area as a sample for the rest of the world? And can any remediation be offered for current vulnerable IoT devices? In this section, we will cover the proposed methodology for the project. The methodology that I will be using is building upon previous research and will use a similar three-stage approach. The first stage is involved with device identification and classification. The second stage involves the device vulnerability assessment, and the third stage involves the data analysis. Figure 3 shows a flow diagram of the proposed methodology. So here we see that we will develop search queries for Shodan, pull out the device banner and IP information, parse that into a device database and classify the data of a sample of that. Then we will run a vulnerability assessment using Nessus, and that vulnerability data will also be parsed into the device database. Once that is complete and classification of the vulnerabilities has been done, we will run data analysis using Minitab. It gives a brief description of the testbed that will be used to run the project. The testbed will be configured in Amazon Web Services. We will configure a Windows machine to host Python, which will be used to develop a script to interface with the Shodan API so that we can pull back data from the Internet of Things for the project. This data will be parsed into an SQL database which will sit on this Windows machine, and this Windows machine will also host Minitab for data analysis. A 3-machine cluster to run the Nessus vulnerability scanner will also be configured. This will also be used to access and scan the Internet of Things for the devices that have been identified for the project. For the results evaluation. Initially, we'll need to take a sample of the data, as there are currently 21 million IoT devices connected in Ireland and the UK. Data will be sampled at random using the database index. We will use a sample size of 40,000. This was calculated using Shodan's formula based on the fact that we have no previous statistics from this existing sample. After this, we will do device categorization. Devices will be categorized into 4 buckets: industrial, consumer, healthcare and others. This will be completed using existing Shodan filters and extraction of data from device banners. A classification lookup table will be built utilizing the known IoT device manufacturing data and the existing filters from Shodan. Vulnerability assessment. Nessus vulnerability scanner will be configured to run a complete vulnerability assessment. This will also be used to classify the risk of each top vulnerability in the device category. It will use the CVSS or Common Vulnerability Score system for this classification. For the presentation of overall results, we will use summary tables and bar charts to graphically display the results from our analysis. We will present an overall summary table with inferred device counts for the entire population for each risk level. We will present an overall summary of top vulnerabilities. We will also present an overall summary of services running on devices. We will present a summary table for each category to include device type. We will present a graph of vulnerability for each risk level, and we will also graph services running on devices for each category. Table 4 here shows an example of the overall summary table. The data here is example data, so we will present each category along with the CVSS risk level from critical to low, the number of devices that we have found, the percentage of devices from the sample, and then the inferred number of devices from the entire population. We will also graph an example of overall top vulnerabilities from the overall sample, and we will do the same for overall services. We will then drill down for each category and give a similar presentation for each category that we have classified of device. This section covers the project plan. There has been a 12-week duration allocated for this project. I have split the project up into 4 separate stages. Each stage is completed with either an interim report or the final report at the very end. Stage 1 is the project initiation and literature review. Stage 2 covers data collection and vulnerability assessment. Stage 3 covers the results evaluation. The final stage, stage 4, is the completion of the final report and presentation for the project. That concludes my presentation. Thank you for your time.